Hello and welcome to the Chapter 4 podcast on Section 4.1. Today we're going to be talking about general properties of aqueous solutions. Before we talk about electrolytic properties, remember a solution is a homogeneous mixture, and aqueous means that it's going to be water acting as a solvent. Okay. One of the ways we can test the properties of an aqueous solution is by looking at its electrolytic properties. Basically, this is a solution's ability to conduct electricity. We can use conductivity meters, which are essentially electrodes, and you can see them in the figure on the right. And we can run electricity through the wires, and if it has the ability to conduct electricity, the electricity will travel through the solution, completing the circuit and lighting up the bulb. We don't always have to use light. We can always use voltmeters and other things if we want to be a little bit more specific. One thing to keep in mind is that pure water does not conduct electricity. We can look at these different solutions here. If we have no ions, notice how we don't see any light in the light bulb, meaning that there's no conductivity. And then you can see that if we have situations where there's few ions, where the light is dim but it's still on, so this is it has the ability to conduct electricity, so it's an electrolyte, but it doesn't do it very well. And then you see one where the light is very bright, indicating that there are many ions in the solution. Okay, things that have conductivity are electrolytes, and things that do not conduct electricity are non-electrolytes. What we find is ionic compounds tend to be, not always, but most of the time, they're going to be electrolytes. If ionic compounds do dissolve in water, what they're going to do is they're going to what we call dissociate. What that means is that they're going to basically separate into positive and negative ions. The polarity of the water attracts either the positive or the negative ion. So if you look closely at this figure on the right, notice how the positive ions are attracted to the negative oxygens from various water molecules, and notice how the negative anion is attracted by the positive end of the water molecule. This process is called solvation, and this helps stabilize ions in solution. You can also imagine you can get to a point where there isn't enough water molecules to handle the salt that you're adding in, and we'll talk about what happens to that later. Molecular compounds in water, they do not separate in water, they do not dissociate. Most molecular compounds are electrolytes with a few exceptions. Acids, it's not the expression, it's the exception. Acids, there are some organic acids. These are acids that are made up of carbon, oxygen, and hydrogen. Acetic acid, where acetate is the anion, is an example of this. And there are many other ones that do this as well. As is shown in the first figure, there are different kinds of electrolytes. Some are strong and some are weak. Strong electrolytes are basically situations where the ionic compound basically completely ionizes in solution. Weak electrolytes are solutes where you only get a partial ionization. Okay, and this happens with a lot of the organic ones and some other ones as well, where you see a low degree of ionization. So these kinds of things can account for differences in the electrolytic properties of various solutions. Remember, a solute gets dissolved. The solvent, which is water, does the dissolving, and we'll talk more about this in class.